Hello everyone, this is Team 9. Korea is a country with 4 distinct seasons, and one of its defining characteristics is the monsoon season, particularly during the summer months. The nationwide annual precipitation is 1,306.3 mm, and the central region, where the Hanyang-Sujang riverine are located, receives between 1,191.4 mm to 1,444.9 mm of rainfall. During the summer season, the total rainfall amount is overwhelmingly dominated by the precipitation that occurs during the monsoon season, which amounts to 804.3 mm. Furthermore, upon examining our site's construction plan, we see that most of the pile driving is scheduled for July and August. This week, we will explore how these weather conditions affect our site's construction process and how our site managers plan to address these challenges. Our site involves cutting through mountain Gyeongdae and working on a terrain with level differences, so if we don't properly handle water accumulation, it could lead to serious accidents. To prevent this from happening, Hanyang Construction planned the rainwater treatment based on the maximum daily rainfall amount in Namyangju City, where our site is located. Based on last year's data, the maximum daily rainfall in August was 262 mm. For our site, the rainfall amount would be 10,996, which the maximum daily rainfall in August multiplied with our land area, 4,196,800. The infiltration rate was estimated at around 10% based on the geological characteristics of the entire site, which means we need to handle approximately 9,896 of water per day. To handle the excess water, Hanyang Construction installed 16 units of 2-inch pumps and 2 units of 3-inch pumps in each section. The 2-inch pumps can process 26.4 per hour of water, while the 3-inch pumps can process 52.4 per hour. Therefore, the daily processing capacity is 10,137 per day for the 2-inch pumps and 2,515 per day for the 3-inch pumps, totaling 12,650 per day. This means that the site can handle the excess water without any issues. In addition, we have installed drainage systems along the site boundary roads, including Sanmaru, and having prepared for the disposal of excess water by connecting 9 temporary grid chambers to the external drainage pipes of the road construction company in advance. This part has already been completed for water treatment on our site. Moving forward, we need to figure out how to handle the additional issues where excess water may occur during construction. Firstly, Hanyang-Sujang riverine is situated on a sloping terrain. As a result, there is a greater risk of rainwater flowing into the front of the first floor shops than in other areas. The initial design plan did not include measures to prevent rainwater from entering the front of the shops. Therefore, there was a risk of rainwater infiltrating the shops if the nearby river overflowed during heavy rain. To solve this issue, we modified the design by raising the level of the shop floors and create a slight slope towards the road, preventing rainwater from entering. Additionally, we added a trench to serve as a pathway for rainwater to be discharged at the entrance of the shops. Moving on to the underground parking lot, as mentioned earlier, there is an expected increase in precipitation during the summer of 2023 compared to previous years. According to Channel A News, the demand for water stop values has increased more than tenfold due to the increase in flood-prone areas. The water stops are water blocking facilities installed in the entrance of the underground floors and the first floor of a building to prevent flooding damage from local heavy rain and other similar events. Flooding damage poses a significant risk to apartments with underground parking lots, especially those like Hanyang-Sujain River Pine, which parking lots are up to the second basement level. Therefore, we must always be prepared to prevent damage from excessive water. Upon reviewing the design of the underground parking lot, we found a flat ramp that connects the ground entrance to the underground first floor and faces the river and external road. By installing water stop at this entrance, we can prevent damage from excessive water and prevent flooding in the apartment. In addition, there is an entrance to the electrical room located on the second basement level. If rainwater enters the electrical room as shown in the pictures, it can cause a power supply issue to the units and even lead to serious electrical shock. This video shows a tragedy that occurred in the underground parking lot of an apartment building in Namgu, Pohang City, Gyeongsangbuk-do. The adjacent stream overflowed due to heavy rain, and the rapid rushing water flooded the parking lot within just 8 minutes, trapping 7 people who unfortunately lost their lives. Only 2 people were rescued. If there had been an electric shock due to flooding in the electrical room on the basement 2 level, those 2 people would likely have lost their lives as well. To prevent such accidents, the framework raised spot of the entrance to the electrical room in the Hanyang-Sujain River Pine apartment was designed to be 500 mm or more above ground level. While it may not be able to completely prevent flooding from a large amount of rain, but it is expected to provide some level of protection. That's not all. Let's take a look at the structure of the top floor of the underground parking lot, not the entrance. As you can see, there is a vertical offset in the roof structure of the top floor of the underground parking lot. Here, we need to understand the concept of staggered jointing. Staggered jointing means breaking and constructing the structure in sections. There are several conditions that require staggered jointing, one of which is the vertical offset in the roof structure of the top floor of the underground parking lot, which cannot be constructed all at once. Another condition can be found in the recent shortage of cement supply, as mentioned last week. On site, there is not enough cement supply, so the construction process that should be completed in one day is being carried out over several days. Cement is a material used to make concrete, so this also leads to a limit in the amount of concrete that can be used in the construction process. Due to these reasons, the process of staggered jointing is necessary during the construction of several concrete structures, especially when there are separate horizontal and vertical frames as in our site. Cracks and leaks occur at the joints between these frames. To prevent such leaks, we installed waterproof raised spot on the vertical parts. However, there is an important point to keep in mind during the installation process of the waterproof raised spot. If concrete is first installed, and the waterproof raised spots are installed separately, the purpose of installing the waterproof raised spot is lost due to the cracks that occur between the 2 concrete structures that were installed at different times, resulting in a higher risk of leakage. Therefore, we proceeded with the process of installing the waterproof raised spots by integrating the vertical parts. Over time, the integrity of the concrete may deteriorate, leading to the possibility of joint formation. To prevent this, we used jack supports on our site. Jack supports are used to support the substructure of underground parking lots or large decks under heavy loads. They are typically installed at appropriate points on beams or slabs to prevent deformation or collapse caused by design loads or cracks that occur over time. At our site, we installed jack supports after PSC installation to prevent the occurrence of potential cracks. So this week, we looked at the handling and preventive measures applied to our site. Next week, we will examine the overall construction process and the considerations within it. Thank you for watching.